let's go through this one. So before I talk about it, let's just do the first statement. Our very first statement is going to be RP equals TQ. Do I need to explain that? And what I mean by that is what are you going to go through your mind process? If I would say that something is supplementary to something else, your next step would be explain what that means. Okay, because supplementary is 180 degrees, right? So if they ever give you like a definition of something supplementary, your first step is always to define what that means. There's nothing to define here. It is just RP equals TQ. There's no way to unpack it. So I think that's a good way to look at it. Can you unpack the first statement? No, not really. And they're both pretty much the same statement, so I'm going to list both of them in the same step. There's nothing to unpack. Does that unpacking make sense? I think that's a better word for it. So if I say two things are congruent, you might say, well, their measures are equal or something. But there's nothing to unpack here, so I'm just going to say that's my given. All right, let's just think about this. So they're saying that RP is congruent to TQ. Maybe I'll color those in. I'll color them in and put that little line that we normally do, but sometimes it's nice just to see a color. These two are equal, and the tick mark would show that they're equal as well. All right, then it says that PS is congruent to QS. That'd be two tick marks because it's a different one. Ooh, that blue barely shows up. But I was here and here. Yes?
Definition of, what was it? A definition of congruent lines? A definition of some.
What step did we do? I didn't do a step yet.
Oh.
I was just doing the given.
Oh.
I'm just saying that these two things are congruent because that's what they told me. We don't have to give any. We don't have to make any statement. It's just given. That information is given to us. All right. So now they want me to prove that RS is congruent to RT. Correct? Amber?
Would you do RP plus PS equals RS, and I think that's supposed to be TQ plus QS equals TS?
Yeah.
I can't read my own.
Well, think about this. We have a bunch of segments, and I want to prove their total lengths are congruent. So I need to first build up to that total length, just like Amber said. I'm going to say this segment plus this segment equals this bigger segment. So anytime we're dealing with segments, parts of segments, we're going to use that segment addition postulate. So we're just going to go right into RP. Let me change that back to black. RP plus PS is going to equal that total length RS. And then we're going to have TQ plus QS is going to equal the other total length. So at least now we're talking about terms of RS and TS being our total length. And we should be able to say number 2 is our segment addition postulate. Segment addition postulate. Anyone have an idea of what we could do next? Grace?
You could use substitution to prove it.
Oh, we could absolutely use substitution to prove it.
Because like RP equals TQ and PS equals QS, so then you know RS could equal TS.
Mm-hmm. Yep.
So the last step is the proven step, RS equals TS because of substitution.
Yep, absolutely. So what Grace is saying, and I'll highlight what she's saying. She's saying, since I know that RP equals TQ, how about I replace TQ for that RP? And I know QS equals PS, so why not just substitute that QS for there? And we'll see what that looks like. That will give us that TQ plus QS equals RS. So I'm saying this segment plus this segment equals this total segment. And that's just substitution, yeah.
Could you also just say like TQ plus QS equals RP plus PS?
We're going to get there. We can't quite jump there.
But isn't that saying like basically the same thing?
Oh yeah, you'd.
We have to get there though.
I know, I thought that was before that step that you just did.
Oh, say it again?
Like doing RP
P
plus PS
equals
TQ plus QS.
But we couldn't do that in step 2 because we wouldn't know enough information. Oh, in step 3, we still don't have enough information. What property would you use to say that?
Substitution.
But we just know this fact, right?
Okay.
So the only thing we could do that, we could replace TQ, QS with RS, but that only works if RS equals PS or something.
Okay.
Okay? So we need to do this first, which is our substitution.
Can you like skip that step and just assume it?
No.
Oh, that's nice.
But our fourth step is going to be the step you're talking about. Our fourth step is going to be, so let me highlight this in a different color. Let's do light blue. Note that RP and PS equals RS, so we can plug that in for this RS, which will now get us our TQ plus QS equaling RP plus PS. So I do need this step first. Do you see why this step is kind of necessary? So then I can actually substitute that in. If you just jump through here, I'm not going to take off 1,000,000 points, all right? Because you kind of saw your way through it. I'm going to give you most of your points. If you skipped this step and went to this step, I'm going to give you most of the points for the proof because I can see where you got that from because it makes sense. And the whole point of proofs is making sense through the problem. All right, fourth one is substitution again. Let me get this out. And in fact, I went a really stupid way about this. I could have just plugged this. I was just looking at my answer right now, and I could have skipped a step and just plugged TS in for this. All right, so yeah, you could be done on this step. I was just looking at it right now, so we could be done on this step. All right, so let's get rid of this right now. If you leave, you can leave it too. I was just thinking about this and thinking about what I did, and I'm like, there's an easier way to do this. I'm going to instead take the fact that TS equals all of this and replace that to give me just straight up to TS equals RS. But that's still substitution.
So you could do all those steps, but you don't need to.
Yeah, you don't need to. There's lots of proofs that I'll do it one way, and there's easier ways to do it. All right, there'll be proofs where I'll use like 6 steps, and you'll be like, is this one that I use 4 steps correct? I'm like, yeah. There's clever ways to do proofs, and then there's less clever ways, but they're all correct.
So do you need the third step even if you just went, like, because I just like assumed that, because like you can obviously see RP at P plus PS equals TS just by looking at number 2, just because if you know number 1.
But here's the problem in that statement is you assumed it.
No one else.
Anything you assume, you should write out. All right. That's why I said I wouldn't take a whole bunch of points off yours, because I think you did exactly what she did. You're just like, it just makes sense that they're both equal to each other, that this is equal to that because this is equal. I get where you're going with it. It's just this is the more correct way.
Yeah, I just thought by what was shown, we could actually substitute them in because of the way it's treated.
Because the way it's drawn, right, and stuff.
No, like, never mind. It doesn't really matter.
But do you get why it's not? Okay. That's all I care about. All right. Remember, proofs repeat themselves. All right, we've seen ones that look just like this one before. This isn't the first time we've seen this almost same exact style of proof. So know how to do this style of proof. And the whole thing behind it is, if I have segments, add them together, see what you can have equal it, and see if you can substitute your way through it. Alright? So generally if you have segments, you're going to use the segment addition postulate. When I grade these, and I'm grading this, first thing I'm going to look for is, did you use segment addition postulate? Alright? I'm not even concerned how you set stuff up or what you went through it. The first thing I'm going to look for on this problem is, did you use segment addition postulate? So this right here would get you a big amount of points. Alright? So make sure you know when there's segments, use segment addition postulate. Amber, yeah. 13. Is a fill in the blank proof one, right? Alright. First one, that's the one that tripped you up, right?
Oh, yeah.
The given one. That one's given. Alright, let's see what we need to prove. So given that these two things are perpendicular, prove that the two angles are complementary angles, right? Did we do this one in our notes? No, I think maybe I skipped this one for this reason. Okay, measure of angle AOC. So this is unpacking. This is what I mean by unpacking. All right, so everyone should be paying attention to this. This is what I mean by unpacking. If I say something is perpendicular, I unpack it to say what that means. It means that this total measure equals 90 degrees. That's the definition of perpendicular lines. I unpack. All right, then we have measure of angle AOB plus measure of angle BOC equals measure of angle AOC. What lets me know that one angle plus another angle equals a bigger angle? 2 people? 3 people? 4 people? 5 people? 6 people? What is it? Just shout it out, someone. Angle addition postulate. Yep. So we're going to use our angle addition postulate. What does angle AOC equal? We do. So can't we just replace that in here? As soon as I know a number, the first thing I'm going to do is I'm going to replace that number and I'm going to use substitution to say that measure of angle AOB plus measure of angle BOC equals 90 degrees. And in fact, your proof is done. Your proof is actually done. If you would say substitution and definition of complementary angles, because that's what complementary means, is they add to 90, I'd be okay with that. But what they want you to do is actually rewrite this statement down here. They want you to rewrite that statement down there. And that's it. It really was. As soon as you know a number and you see it here, replace it with that number. All right. That's why we unpack. Look at the only 2 things we did. We unpacked a statement and we used the angle addition postulate. That's it. So for those of us that are really dreading these proofs, the 2 major things you need to do is unpack and use angle or your segment addition postulates. All right, and then it's just plugging stuff in and moving stuff around. All right, yes?
Number 11?
Number 11. Get that guy in there. So in number 11, we have perpendicular lines all over the place. And then it says, oh, you know what what's the problem with number 11? Yeah.
It's not a full 180 degree angle. It's FBC is missing.
Yeah. But they're trying to trick you. That's the whole part of this problem, is to try to trick you. They're trying to make you think you're looking for 180. So let me show you what I mean. So they said measure of angle ABD equals 3x minus 12. So ABD, let me highlight that in red. That ABD right there, that equals 3x minus 12. Then they tell me that DBE equals some length. So DBE is right here. That is going to be my 2x plus 2. And then they give me a third angle. That third angle is completely useless. Because I'm going to look back at the directions. It says that BE is perpendicular to AC. So that means those two angles I just found equal 90 degrees. So I don't even need that third angle. It was there to trick you into thinking that you had to go to 180. This plus this has to equal 90 degrees. Does that make sense, Sabrina?
Right, yeah, but you, on the test, when if there a problem like that comes up, like, how would you know to, like...
I'm not going to give you a problem like that.
Oh, okay.
Because this is kind of a trick question, because you see three angles and you're like, what do I do with three angles? Because I can't set them all equal to each other. I don't want to add them all up. So it's kind of a trick question to see if you would stop and think about the fact that this is the right angle, stop at these two angles. All right? Other questions? Yeah.
Number 17.
All right, this has to be the last one. That was number 17. Okay, 17 says to express DOE in terms of x, y, or both. So let's look at DOE. DOE. All right, DOE. All right, so what I'm going to look at is, I'm going to do as best I can to come up with, yeah. Oh, yeah. Do you know how to get this one?
Oh, yeah, I got it right.
Okay. So I'm going to look at vertical angles first. I'm going to say, well, that equals y. All right, I'm going to get all the information that I could possibly do. Well, in fact, that's pretty much done.
Oh.
Because this is 90 degrees, right? So this angle here is going to be 90 minus x minus y.
I forgot to do the vertical angle.
Yep.
See it. Okay.
Always do your vertical angles. Always check for 180, 90, those key things. All right, good then? All right, awesome. If you still have questions, please see me after class or put something in that bin and I'll try to post a video on it because we got to get to today's lesson. We did that one. We're just going to go through two proofs real quick. So we're going to have a little bit more time, but that's okay. All right, the first one says that AOD is as shown. Sometimes they do that. Your given is just a picture. All right, in those cases, we aren't going to put anything down as given. Because otherwise you have to put drawing, given. We're not going to. So we're going to skip this given step. We are given a drawing. It says prove that this big angle is angle 1 plus 2 plus 3. The problem is the angle addition postulate, I'm only allowed to add 2 angles at a time. All right, you can't add all 3 at the same time. What?
Why?
Because that's what the angle addition postulate says. It says angle 1 plus angle 2 equals a bigger angle. But it's not as hard as you think this one's going to be. We just have to break this down and eventually just add two angles together. Yes?
But you do like AOD equals, like AOC plus COD?
Yeah. That is a good, that's not our first step.
Oh.
But was you going to say kind of the same thing?
Yeah, I was gonna say like angle 2 plus angle 3 equals blah blah blah, and then that angle plus 1 equals.
The whole thing.
Yeah.
That is 100%. You have the proof down. All right. If you put that on paper, even if she messed stuff up along the way, that'd be like 90-some%. Even if you messed up how you said it. All right. So both you had the exact same idea. So what Grace said is, hey, I only can add two angles at a time. So let's just say angle 1 plus this big angle equals that total thing. And then Lydia expanded upon that. Well, I can say this big angle is this plus this. So our goal is to say this plus this equals this angle. And then this angle plus this angle equals the whole thing. And we are done. We proved it. All right, then we can go ahead and say angle 1 plus angle 2 plus angle 3 equals this total thing. So I gave myself 3 spaces, so I want to make sure I keep it kind of in the same order. But we'll do what you said. We'll change it a little bit. How about we just start off with BOD, because that's one you talked about, right? So we're going to say measure of angle 2. Let's go to black. Measure of angle 2 plus measure of angle 3 equals the measure of angle BOD. And the reason is, surprise, surprise, angle addition postulate. It's almost like that shows up a lot. Yeah.
Yeah, what happened to given, the AOD given?
Like I said, we can't do that given, because they just said it's a drawing.
Oh.
So you could either draw this picture and say it's given, or we could just skip this given step by saying, hey, I can't really rewrite the drawing, so it's implied given. Okay. All right, so we have, this is 2 plus 3. And then we'll use Grace's thing that, hey, this big angle plus this small angle equals the bigger angle. So let's just say measure of angle BOD plus that measure of angle, I'm going to call it 1, because we can do that, equals the huge big one, which was AOD.
Would there be substitution?
It is going to be substitution. Oh, I thought you meant the next step is going to be substitution. No, this is still angle addition postulate. Because I'm adding 2. I thought you saw what the next step was going to be. This is still angle addition postulate. Anytime I'm adding 2 angles together, and they're fresh, right, I'm just pulling them down, it's going to be angle addition postulate. But then we are going to use substitution, because I'm going to substitute all of that in for angle BOD. I'm just going to change the order of it to measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals measure of angle AOD, which is substitution. So you both had that, right? Whether you could write that perfectly in a proof or not, I'm not overly concerned about. Because you could have fumbled your way through this, and I would have known what you were talking about. All right? So for those of really stressing about proofs, as long as you can kind of see these ideas and write them down in a semi-meaningful way, you'll get most of the points for that given proof. All right, any questions on this proof?
Sorry.
You that mad about this proof? I don't think you saw her face either when she threw that pen. Just like, such anger. Okay, last proof. Last proof. We've seen this proof before, actually. We've seen this exact proof. It says, given angle 1 and angle 2 are vertical angles. We're going to prove that angle 1 is congruent to angle 2. So our first thing is going to be angle 1 and angle 2 are vertical angles, given. Before I even look at that proof, I always ask myself, can I unpack that statement? Is that statement important on its own? How are vertical angles important?
You can say angle 1 and angle 2 are congruent.
Absolutely. So we can say angle 1 and angle 2 are congruent. I'm just going to put the congruency sign between them, if that's okay.
Oh, that's it.
That's the proof.
Oh, never mind. We can't do that.
Oh.
Scratch that. Scratch that.
Dang.
I forgot that's what we're trying to prove. That'd be nice, though, right? Yeah.
Would it be like angle 3 is and angle 4 are vertical angles?
Kind of. We are going to use angle 3. I forgot we can never go to the first step and actually prove it. I thought we were doing a different proof. I picked a different one. So our goal here, Amber, do you have an idea, or are you just rubbing a headache? No? Okay. That's okay. Does anyone have an idea of what we could go through? We are going to use 3, yeah.
Would you invent something with 180? Like, angle 1 plus angle 3 equals 180? I don't know if that would help at all.
Well, let's try it.
Okay.
Let's try it and see what works, okay? We'll try it and see if it works. So angle 2 plus angle 3 equals what?
180.
Equals 180. Let's try it. Let's see if that works. Measure of angle 2 plus measure of angle 3. And if you don't think it's going to work, don't write it down. And then we'll try, I'm just going to use the other side too, okay? The measure of angle 1 plus measure of angle plus measure of angle 3 equals 180 degrees. Cool. Cool. So I have them both equaling 180. I'm just going to use it's going to be the angle addition postulate. You could have used that it's a straight angle. That's what equals 180. Angle addition. You got the next step?
Can you call it like definition of angles on a line?
Like I said, you could, because that's what a straight angle is. Use the angle addition postulate. It's a more powerful one. I always pick, if it's possibly 2, pick the more powerful of the 2. And straight angle is something that's implied by a drawing, not very strong. Angle addition postulate, it's a postulate, it's strong. But I wouldn't take points off, okay? Step 3. Man, I would love if angle 1 and angle 2 were on opposite sides of each other. Even if they had other stuff attached to them. Sabrina?
Angle 1 plus measure of angle 1 plus measure of angle 4 is 180 degree.
Don't throw in a new angle,
Okay.
because 4 is not up there. Lydia, do you have an idea?
Measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3, and then just
Yeah, that's exactly what I would do. I would say, I want measure of angle 1 and 2 on opposite sides, so we can do that through substitution. I can throw this guy in for 180 because they're both equal to 180. So I can put that on the other side through substitution. So I can absolutely say measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. That's substitution. I feel like, I mean, we're fine. I just did this in a slightly shorter fashion. Oh, I know what I did. I skipped the given, but that's okay. We're going to do an extra step. It'll be done in 5 steps. Grace, what do you think our next step is?
Could be subtraction, because you can subtract.
Close. I would have been okay with that. So Grace is saying subtract measure of angle 3 on both sides. I would not take any points off if you did that. The more correct way is to first say that measure of angle 3 equals measure of angle 3. And then the groans are let out in the classroom like, oh, do we have to say that? We have to say that to be 100% correct. On a test, I'm not going to take points off, okay? So that's a reflexive property. And now we can say that measure of angle 1 equals measure of angle 2, because we're going to subtract measure of angle 3 from both sides, and that is our subtraction property of equality.